Hey everyone, selamat sejahtera. Cikgu here. Okay, so exam season is coming up, right? No worries, I've got you. We're going to do a super fast revision on the chapter about our amazing planet, Earth.
So, let's just jump right in. Have you ever really thought about it? What makes our planet so special? I mean, why is there life here and, not on Mars or Venus? Well, it turns out there's a secret recipe, a few key ingredients.
And believe it or not, we're going to break it all down in just 5 minutes. Yep, everything you need to know for this chapter, all packed into one quick explainer to get you ready for that exam. You ready? John, let's do this. All right, first things first, we need to think about the big picture. See, our planet isn't just some big, boring rock floating around in space. No way. It's more like a super complex living machine. It has all these different parts, and they all have to work together perfectly to make everything, well, work. So remember those secret ingredients I mentioned? Well, here they are. They're these 4 major systems. You've got the atmosphere, that's the air zone. The hydrosphere, pretty easy, that's all the water. Then the geosphere, that's the rock and the soil, the ground we stand on. And the most important one for us, the biosphere. That's life. Us, the plants, the animals, the whole shebang. And the key thing to remember is all 4 of these have to work in harmony. Okay, now let's zoom in a little. We're going to look at the 2 big protective shields of our planet, the air and the water. These are what keep us safe from all the crazy stuff out in space. First, let's take a trip up, way up into the sky. So as we go up, you need to know these 5 layers. Right at the bottom, where we are, is the troposphere. Think weather. All our clouds and rain happen here. Go a bit higher, you hit the stratosphere. This is where the ozone layer is, our planet's sunscreen. It's also super calm, which is why airplanes love flying there. Then you've got the Mesosphere. This one's a hero. It burns up meteors, like a bodyguard for Earth. Above that, the Thermosphere bounces radio waves around, which is awesome for our communications. And way, way out at the very edge is the Exosphere. That's where you'll find all the satellites orbiting. And you know what? It's not just the air that has layers, the ocean does too. Right at the top, you have the surface zone. It gets tons of sunlight, so naturally, that's where most of the fish and sea life hang out. But as you go deeper, you get to the Twilight zone, getting a bit spooky, not much light. And if you go all the way down, you're in the dark zone, pitch black, 0 light, and crazy high pressure. So for your exam, just remember this simple rule. Where there's light, there's life.
Okay, this is a super important point, a real exam favorite. A lot of people think we're like running out of water or losing it somehow, but that's not really true. The total amount of water on our planet, it's constant. It stays the same. Why? Because of the water cycle, right? Evaporation, condensation, rain, it just moves around and changes form from liquid to gas to liquid again. It doesn't actually disappear.
All right, so we've been up in the atmosphere and down into the deep sea. Where to next? Well, we're going to drill down. Let's go on a journey right to the very center of the Earth. And how are you going to remember all these layers for your exam? Easy. Just picture a yummy cuy lapis. You know how it has all those nice, neat layers? Well, the Earth is kind of like that. One layer on top of the other, all the way to the middle. So, what are the layers of our quay? First, on the very outside, there's the crust. It's super thin, and it's the bit we live on. Go deeper, and you're in the mantle. This is the thickest layer by far. Then you get to the core, which is in 2 parts, a liquid outer core, and then right in the middle, a solid, incredibly hot inner core. So just remember, thin crust, thick mantle, liquid outer, solid inner.
Okay, class, get your highlighters out for this one. This is a number you absolutely have to know. How old is planet Earth? The answer, based on studies of meteorites, is around 4.5 billion years old. Yeah, that's billion with a B. That's a huge number.
So, a planet that's 4.5 billion years old, you can bet it's seen some changes, right? It's not static. Our planet is constantly changing, being reshaped by some really powerful forces. Some of these forces come from the outside, and some come from deep, deep inside.
And these forces have names you need to know. First, you have exogenic processes. Exo kind of sounds like exit or outside, right? So these happen on the surface. Think of wind and rain slowly wearing down a mountain. Then you have endogenic processes. Endo sounds like in. These are forces from inside the Earth. This is the stuff that causes earthquakes and makes volcanoes erupt. Easy, right? Exo, outside, endo, inside. And all this pushing and pulling from inside and outside, it powers Earth's own little recycling program. I'm talking about the rock cycle. So it starts with igneous rock, that's just cooled down magma or lava. Over time, bits of this rock get worn away and settle down in layers, getting squeezed together to form sedimentary rock. Now listen up, this is a huge exam tip. Because this squeezing process is kind of gentle, it can trap and preserve dead plants and animals. That's why fossils are only found in sedimentary rock. Got it? Okay. And finally, if you take any kind of rock and cook it with a ton of heat and pressure, it transforms into metamorphic rock.
So all these cycles and processes happening for billions of years, they've basically cooked up some incredible natural treasures deep inside the Earth. Let's talk about these resources, the stuff that's super important for us today.
We just talked about fossils, right? The name itself just means something dug up. But these aren't just cool skeletons you see in a museum. Oh no. When these ancient plants and animals get buried for millions and millions of years, they turn into something else, something we literally use to power our lives every single day.
And here they are, Earth's hidden treasures. We dig up minerals that are super valuable, like iron for building, and gold for, well, gold. We also get these things called rare earth minerals. You might not have heard of them, but they're in your smartphone and your computer. And then the big one, those ancient organisms I mentioned, they become fossil fuels, coal, petroleum, natural gas, the stuff that runs our cars and makes our electricity. But here's the thing, living on this powerful, active planet and using all its resources, well, it's not all easy. It comes with risks, and it also comes with big responsibilities. So for our last section, let's talk about the challenges and, our role in all of this. Remember those endo forces from inside the Earth? Well, sometimes they can be really dangerous. We call them geohazards. But the good news is we're not helpless. We've developed some amazing tech to give us early warnings. So how do we see an earthquake coming? We use a seismograph. How do we spot a tsunami? With radar and satellites. What about landslides? We can actually listen for them with acoustic sensors. This table right here? Perfect for your last-minute revision.
So, there are natural dangers, but we also have to talk about the problems we cause ourselves. When human activities aren't planned properly, they can have a massive impact. For example, when we cut down too many trees, that's deforestation, it can lead to soil erosion and even contributes to global warming. When we mine for minerals without care, we can end up polluting our rivers. Even farming, if we use too much fertilizer, it can poison the water underground. The key takeaway here, the big idea, is that we need to manage these activities sustainably.
And that's it. We've just blasted through the entire chapter in just a few minutes. We've seen how our incredible 4.5 billion-year-old planet is this amazing living system. Its past is written in the rocks and the fossils, but its future? That part hasn't been written yet. And the real question is, what role are you going to play in that story? Something to think about, yeah? Okay, that's all from Sigu for now. All the best for your exams. Study smart.